So good morning students. So in this particular lecture, just a minute. Okay. In this particular lecture, we will start about the second biasing technique, that is nothing but emitter stabilized bias technique. Okay. So just I want to take the pen. Hope you have solved this problem based on the previous biasing technique, that is nothing but the fixed biasing technique. So the thing is that in the next or this upcoming lecture or in this today's lecture, we will see the emitter stabilized bias technique. Okay, emitter stabilized bias technique. So what is the difference between that is nothing but just they have added one resistor that is connected across our emitter terminal. Okay, emitter terminal one resistor is connected, and as it is connected to emitter terminal, its name is Re, and if resistor is connected, it cause to flow the current is called as IE. So to stabilize the circuit, because it some kind of unstable over there, because the whatever the value of IB is totally depend upon my VCC. If my VCC is changed, then what will happen? That my IB is changed. So that's why we have to make the circuit which should be stable, which will be more stable. So we have added the RE over there. So we have to see how to analyze this thing. Analysis means what? What you have to do? We have to calculate the value of IRB, and we have to calculate the value of VCE from this one. Okay, because whatever the graph is there, that is nothing but output characteristics of common emitter, that is nothing but the IC versus VCE. If you are not remembering this thing, then go through the playlist and watch the common emitter configuration. So these are the graph. Okay, these are the graph. Like when you will get the characters for different value of IB from this one. So we required IC and we required VCE. That's why we are calculating. And if we know the value of IB from this bit, IC is equal to what? Beta times of IB. Beta times of IB we are getting. So IC is nothing but beta times of IB. From this we can calculate things. So if you want to calculate, then again apply a KVL at input side. If I am rearranging the circuit, I can draw like this one. And if I am applying KVL from this end, okay, like this one or in this one, you can apply clockwise or anti-clockwise depending on you. So minus to plus VCC, because if I am going from lower potential to higher potential, so I have to write use the plus symbol. Then here drop you have to calculate, because it's voltage Kirchhoff voltage law. So how to calculate this thing? So plus to minus, I have to write minus here, it should be okay. I will say to you what exactly it means. Here in this line something is there, so I will drop this portion. So that is nothing but VCC minus IB RB over there, IB RB minus VB minus IE RE is equal to 0. But as far as my graph is concerned, there is IE is absent. So we have to find out the relation between IE and IB. So how to find out the relation between that? IE is equal to, we know that IE is equal to IC plus what? IB. And IC is nothing but what? IC is nothing but what? Beta times of IB. If I am taking IB common from this one, so I will get IB common, then I will get IB is equal to IB in bracket 1 plus beta plus 1 I will get, that is nothing but IE is equal to beta times of IB. So simultaneous from this equation, if I am putting the value of IE is equal to beta times of 1 plus beta IB. If I am putting this one, the equation will be like this one. Erase this portion. So VCC minus IB RB is it okay, and instead of IE I have written beta plus 1 RB and RE. So from this I have to calculate the value of, again what, we have to calculate the value of IB from this one. So I will shift the IB term over there. So what will happen? This IB will plus and this term will also plus. If I am taking, then what is the remaining? VCC and minus here one term is also again remaining, that is nothing but my VBE. Minus VBE is equal to 0. So remaining is VCC minus VB Okay, and if I am taking the common from IB common from this, so RB plus 1 plus beta RE, 1 plus beta RE over there, and this will go to divide, and the resultant will be IB is equal to VCC minus VB divided by RB plus 1 plus beta RE over there. So you can calculate the value of IB from this one. Once you are getting the value of IB, you can calculate the value of IC. So how to calculate the value of IC? By just multiplying IB by beta, IB by beta. So IC is equal to what we are getting? We are getting the IB, IC is equal to beta times of IB. Okay. So at the output side, this is the diagram, and if you are calculating the output side, this is my output side. Okay, and this is my input side. Here, this portion is my input side. So I will drop this portion first. Okay, so output side, this like this one. So if I am calculating the KVL across this one, so what will happen with this KVL? Start from anything. So that is nothing but, if I am going like this one, so plus to minus, so VCC will be minus over there, or I will start from this side. I will start from this side. So minus to plus IERE, okay, plus IERE, then minus to plus again, plus VCC, again here to here, so minus to plus again, plus ICRC and minus VCC. And from this, what you have to calculate? Which value calculate? We have to calculate the value of VCE. Okay, so if I am saying, so if I am shifting this remaining thing to right hand side, so what will happen? VCE is equal to VCC. Okay, what will happen in this case? VCC will go to that side by plus, and remaining minus IE RE and minus IC RC. Okay, this you are getting VCC, we are getting this equation. Okay, we are getting this equation. How we are getting this equation? We are shifting remaining term, and VC remains as it is, and remaining term to the right hand side. So we are getting this side. So from this output IE current is not required, because if you are calculating, you know the characteristics, that is nothing but the IC versus VCE. So output side we required what? We required what? IC we required, not IE also. In the input side we have replaced IE by IB. Why we are required? Because my output characteristics, input characteristics are IB versus VBE. That's why IE is not there, so IB is there. So we have represent my IE with respect to my IC, IB over there. So in the output side, what you have to do? We have to replace this IE by IC. So IE is approximately equal to IE, because IE and IC are the same currents are there, near about same value is there. Okay, so same value we can replace IE is equal to IC. If I am putting this value, so what I am getting is VCC minus, if I am taking IC common, so minus IC RC plus RE over there, and from this I can say that this is the equation for what? Is the equation for VCE. Okay, then double subscript notation. How to write down double subscript notation? So yeah, from this one, VE is equal to what? VE is nothing but the drop across this, that is nothing but the IE and RE, IE and RE. From this I will get VE is equal to IE RE over there. Okay, then VC is equal to what? VC is equal to, how we are calculate this thing? VCE is equal to what? VC minus VE, and we required what? Which value? We required value, which value? VC we required. So if I am shifting VE to the left hand side, then what will happen? VCC plus VE is equal to VC. So this is written over there. And if I am putting the value of, this what you can say, VC in this particular equation, so I will get VC is equal to VCC minus ICRE over there, VCC minus ICRE. And VB is equal to what? VBE is equal to what? VB minus VE. Okay, VE over there, and VE's value is what? We have calculated this thing, that is nothing but what? Here, just a minute, is nothing but the drop across this IRE, this is nothing but my VE. And if I am calculating, then I will get the VB is equal to VCC minus IB RB, and from this I will write as VB plus VE over there. That is the same one. Here this is the same one. How? Just a minute. I will rub this and I will tell you how how we are getting VBE is equal to VB minus VE, and if I am calculating the value of VB from this, so this will shift to this side, so VB plus VE you are getting. Okay, VB plus VE you are getting. So this is the thing. So again, improves bias technique. So by adding more resistance, that is nothing but the RE, so your transistor will be more stable one. Okay, more stable one. So depending on the formulas. So what exactly mean by saturation? Saturation is nothing but what? Suppose you are studying for some hour, and at last you are getting nothing. So this is nothing but the saturation condition. So like this one, current will happen. Current will be increasing, first case increasing, and after that it will get flat. It will get saturated. It will get saturated over there. So this is nothing but the saturation condition. So I think we have to stop over there. So in this lecture we have studied the which technique, emitter stabilized biasing technique for more stabilized circuit. So thank you very much for attending this lecture. Thank you.